So benzoyl chloride, so that's this starting material, reacts with methanol to form methyl benzoate as shown below. So select the structure of the first tetrahedral intermediate that forms in this reaction. So we have an acid chloride. And if we have methanol, we have a neutral nucleophile. So we have a common pattern for these nucleophilic acyl substitution reactions. So the very first step in these conditions is your neutral nucleophile is going to attack the carbonyl carbon and push electrons up onto the oxygen. So what we want to do is draw the structure of what forms from that attack. So we can draw that up here. So we see that we still have a benzene ring. We have a bond from that benzene ring to where the carbonyl carbon was. And we no longer have a double bond to the oxygen. It's now a single bond, and we put electrons onto that oxygen, so it now has a negative charge. We still have the chloride on there, so we still have chlorine. And this oxygen from the methanol has formed a new bond there. Okay, and then that oxygen is still attached to hydrogen on one side and a methyl group on the other side, which means with 3 bonds and 1 lone pair that has a positive charge. So this is what happens after the first step of the reaction, and we call this a tetrahedral intermediate because we're looking at the change to that particular carbon atom. So it is now sp3 and tetrahedral, and it started off as sp2 and trigonal planar. So that's what we mean when we call it the tetrahedral intermediate. We're focusing on the change to that acyl carbon. So here's our structure, and so it is option D.